Hello, everyone. Thanks for taking some time out to spend with me this afternoon. We'll call it afternoon. So I am Josh Cox, CEO of OXIT, and going to talk about product design for success and take you on my journey and share a little bit around our experiences. Hopefully, you guys can learn something from that. I think all of product development is about trying to dodge the pitfalls and all the issues that can come about. So how did I get up here on this stage talking to you? 8 years ago, I was working with a company, and we were asked to solve an interesting problem for the American and Kenya Red Cross. We're asked, they were on an initiative to reduce fire deaths by 50% over 5 years. And we got to respond to that. I deployed a LoRaWAN network in Nairobi, Kenya, 8 years ago. And I've been kind of addicted to LPWAN ever since then, and have been learning and helping other companies leverage LoRaWAN technology. Here you can see me in Nairobi, Kenya, plugged into an outlet, setting up a multi-tech gateway, probably the only outlet within a mile radius. A really interesting process. So one of the things, you go to look at product development and as that process goes, here you can see me sitting in the background just very concerned around, did we test this product enough? Is this thing ready to shine? But what was really interesting is learning all these crazy questions these people were asking. And they were crazy because you just wouldn't expect people to ask them. We were developing an environmental sensor. It was getting deployed in the building. And we were getting asked questions like, if there's a fire, should we throw the sensor into the fire? We also had people taking the batteries out of the devices because the batteries were worth more than a day's salary. These questions would have never came up throughout normal development, but I really enjoyed the Red Cross's approach to this. They were, let's dive in, let's figure it out, let's fail early and fail often, but fail cheaply. If you can, that's an important part of this, right? So as I was looking at that and thinking about product development, right, I recalled this like sales pitch, which is you're only so many no's from like that next big client. Right, we implore people to go out to land that next big deal, go through the no's and find that yes. And hardware's a lot the same, right? All these devices out here have bugs, every single one of them. Getting that right product out there requires us to go through the failure. So my attempt here is to just kind of share some light on where we've seen failures in LoRaWAN over the last 8 years. Hopefully you can dodge those potholes and be successful. So what's interesting about this on the left there, I'm helping a technician figure out that he's hooked the GPS into the LoRaWAN radio. If anyone's familiar with the multi-tech protocols, the antenna ports there on the back are easily swappable, and despite being color-coded, these guys are climbing up and down a tower trying to diagnose this in the field. But my favorite thought about this was on the right. When I showed my mother this picture, she asked, "Is what you're doing legal?" And I really enjoyed that question back then, but then I reflected on it putting this together. In the last 2 years, we've been thrusted into the crypto environment, and I've heard terminologies like pyramid scheme brought up on, casual interactions now within LoRaWAN. And if you don't know what I'm talking about, I implore you to look at how the crypto and all that's coming together. And whether or not it's a crypto scheme or not, it's irrelevant. It's just wild to think about how it's evolved. And we as people have to realize that there's potholes coming up there, and we need to be thinking about how people are going to be perceiving our technology. In the same way, those users who thought, should I throw the sensor into the fire, people are going to be thinking, this generates crypto, and how does all that work? And people are asking questions like, is this a pyramid scheme? Questions I wouldn't have thought I'd ever be answering coming in as an IoT guy working on technology, yet I'm answering that question on calls now. So who is OXIT? OXIT is an IoT engineering services company. I boldly keep saying we're the largest IoT engineering service firm on the planet that focuses on LoRaWAN. So I'm waiting for someone to say they have a bigger team, so I'll keep saying that until someone says they do. We've got 130 engineers, all focused primarily on LoRaWAN development. We do everything from the hardware, the firmware, the cloud, and the applications, and everything that goes into helping companies be successful with LoRaWAN. We help navigate not just where the standard is, but where the standard's going, and help companies make decisions and design for tomorrow, not just today. That's my sales pitch. I'm done talking about that. I'm going to go into just sharing some of the stories and things that I've seen along the development pathway and things to try to avoid if you're looking at developing a product. So quick agenda, just going to run through a couple of these one by one, and then I'm done. So one of the first questions I find a lot of companies enter is module. Should you use a module? Should you go chip down? And this question is so interesting because A, it's made quickly. I find that companies are committed. We're going to do it this way. And there's so much complexity even now in that question. Supply chain has brought up an interesting nuance in this, right? If you're using a module today and it's got 2 parts on it, you're maybe waiting on that module vendor to get their parts before they even put a module down. But second to that, right, if you use a module, how are you going to get support? There's a lot of module vendors out there that don't even know what LoRaWAN is. How are you, on a shoestring budget, developing a product, going to get the attention of this module vendor to answer your question? It's very difficult. So get out there and look at their forums for these modules. If you're in that kind of shoestring budget place, make sure that you can get your product to market because you're going to need help. And unless you have a forum or somewhere where you can ask questions, you're not going to be successful. There is a place for chip down, though, certainly in high volumes and things of that nature. So, I tend to segment getting your product live, getting it out there, getting it functional, and then making it cost-effective as you can. Trying to combine those two is expensive. So unless you're dealing with a big budget, try to focus, get the module, get your product out there if you can find the forum and you find the right module that has the support you need. But then focus on the chip down if you've got the high volumes and you're already there and you've made it there. RF stumbling blocks, this one's fun for me. I see a lot of, I'm sure most of you guys know about LoRaWAN's range. It's funny to read and talk to people who say, I tried LoRaWAN and I didn't get the range we thought we would. And I say, well, how did you implement it? And they say, well, I took the reference design from Semtech, I put it on a board, and it didn't go as far as they said. And I said, well, what tuning components did you use? Well, in the reference design, they weren't called out, so I grabbed one of their dev kits and I ohmed them out and I figured out what the parts they used and I put those on the board. That's not tuning. It's very different than what traditional IoT modules are, and so it's not a surprise that we're making this mistake. You know, if you look at Wi-Fi and Bluetooth, a lot of times our modules have the RF integrated. And so because of that, we're leveraging that and we're fine. But when we switch over to LoRa, the antennas typically aren't on the modules. So now you're asking your hardware engineers, say, put an antenna on there, copy the reference design. Why aren't we getting this done? But you likely may not have an RF engineer on your team, and you haven't tuned your design, and it's not going to work as well as it can or should. So you've got to tune that RF circuit, make sure it works well. In addition to that, when you tune, think about your end application. So if you're putting a device near metal, if you're putting a device near human skin, if you're putting a device and going to drench it in epoxy, all of that is going to affect the RF performance, and that should be tuned with that in mind. You can't tune it without those things. So if you're going to be mounting a sensor on a piece of metal or on a pipe, tune it with that piece of metal and that pipe there. So scale hiccups. I was in the other room earlier. I hope most of you guys know about helium. If you don't, it's certainly got a lot of buzz, so I imagine I'm safe to assume that. What's really interesting is looking at like these rack gateways. I just saw those guys, and I can recall in the height of all the helium buzz, these guys had these factories set up. The only way to provision these gateways was to turn them on. They broadcasted a Bluetooth signal. You had to get a phone out. You had to pair to it, give it the helium credentials, and that's how you set it up. Now, a lot's changed since then, but it's important to think about how it started. These guys were trying to do thousands of gateways, and they had to get factories and plug up all these devices, turn on all these Bluetooth signals, pair to each one. It was cumbersome. Yes, they solved it. Yes, the market got that past it. But if you think about that in the beginning, if you're developing a product, how are you going to provision it is important. Don't skip that step and think about bulk provisioning. Even if you don't think it's applicable, how are you going to bulk provision your product? How's the end customer going to bulk provision it? It's important, and if you wait, you're going to get bit by that, because you're finally going to get that customer who doesn't want one, they want 10,000, and they're going to go, how are we going to provision this? And you haven't figured that out yet. And it's a bad time to figure it out at the end. So mobile apps, working with your LNS, trying to think about that process of how you go from manufacturing floor to device provisioned on my end customer a solution is a big play. FOTA, if you see our booth out there, you can see we're heavily promoting FOTA. Although we are an engineering service provider, we came here with just FOTA plastered across our booth. And it's because we feel like it's the largest gap in the marketplace. If you're going to deploy 100,000 devices, we can all be honest, you're going to deploy 100,000 devices with a bug on it. Every single device here has a bug. These TVs, every product, they all have bugs. If you don't know about firmware engineer and you think your product doesn't have a bug, your firmware engineers are lying to you. There's a bug in your product. Now, is it a major bug or a minor bug? Now we get to nuance. So I like to think about how happy a company is when they sell 100,000 products and how sad they can be when the firmware engineer has to walk into the CEO's office and say, those 100,000 devices we just shipped have a major bug. You can bankrupt your company, you can crush it. You can take everything that's positive about it and take it all away. So when you think about firmware over-the-air updates, a lot of companies skip it, and it's their first product. It's the firmware engineer, he's a junior guy, it's his first product. You know, let's be real. We're going to have issues, and how are we going to solve them when we find them? The other nuance here is when you scale up, the issues really shine. You know, you may have ran 1,000 pilot and not seen a problem, and do 100,000 and find the problem. It's all about percentages. So recognize that even if 1,000 work, that doesn't mean 100,000 is going to look the same. You might find problems, and you have to answer the question, am I going to be able to address this, or am I going to ignore it until it shows its ugly face and tears my company down? So I've seen big companies, massive companies, even leverage this, though, and do it the wrong way. They had the ability, and then they end up breaking all their devices. They had the power to OTA and didn't take it seriously enough, and then also didn't have the processes in place, and they bricked all their devices to a firmware over-the-air update. So with great power comes great responsibility, too. We have to think about these things through an objective lens and make sure we're doing it the right way. But consider memory. Think about not just where your application is now, but where your application will be. A little bit of extra memory can go a long way. Don't shave pennies where you shouldn't. Memory is not one where I think you should be barely making it with a new product going out the door. You need some headroom there so that your application can evolve, the stack can evolve, and you can set yourself up for success. Working with an LNS partner that has the support for this. Most of them are on board now and moving in that direction. But you know, if you rewind 8 years ago, firmware over-the-air updates weren't even in the stack. Now they're part of the standard, and we see things moving in that direction. Power consumption. So this is an interesting one. I've seen all sorts of devices fail in this category. One is coin cell batteries. Devices that run off coin cells typically aren't using normal coin cells. They are either using a high pulse output coin cell, or they're using a circuit to be able to output the power you need. But take into account how temperature affects that output current and how it's all tied together. If you're deploying a product for outdoor use case, make sure you test it in the temperature range you're going to use it in. I say this for a lot of times we don't have the temperature chambers. Throw it in a refrigerator. Get out there and test your product in cold environments if you're expecting it to work. And keep a careful eye on that battery. I've seen people run tests in cold chambers with hardwired and then expect the battery to just work. And ignoring the impacts of temperature on the battery can be catastrophic. But beyond that, look at power consumption from a holistic view. Your hardware team should be working on it. Your firmware team should be working on it. Everybody, and even your business logic team should be working on it. Business logic, how often does it really need to transmit? Do I really need that data every hour? Can I support it every 6 hours? That can help the device last longer. But that extra battery life could be used for a firmware over-the-air update to save your business when they have an issue with their firmware. Think about it from the hardware side, making sure your device is going as deep a sleep as it can. That's not just firmware, though. You can do some things in hardware, like with having wake-up pulses that trigger the MCU to wake up and interrupt and things of that nature. And certainly on the firmware, we've got to be going to that deep sleep, but also making sure that device wakes up and things of that nature. Secondarily to that is the stack doesn't handle everything. So the LoRaWAN stack you might be leveraging, it doesn't automatically take into account the back-off joins. You know, if you try to join the network and it's not there, do you immediately retry or do you wait some time? How long do you wait? That's also the business to come in and say, what's appropriate? How often should it be trying to join? What are we trying to accomplish here? What I find is that everyone just assumes the stack handles it first. Then they find out it doesn't, and then they implement it poorly, so they don't have any back-off. So the device is sitting there trying to join every 5 seconds, every 5 minutes, burning through a battery because someone unplugged the gateway. You got to think about, test the device with the gateway unplugged and make sure it'll last as long as you think it should. And then adaptive data rate, ADR, that's essentially the device yelling as loud as it needs to. So if you don't know about ADR, that's just the adaptive data rate. So are you broadcasting at max power even though the gateway's 10 feet away? You don't need to do that. ADR is a feature, you can enable it, and it'll take care of some of those things. That'll increase your battery life, but it'll also make your other devices work better because they're not having to shout over each other, even though they got 2 different gateways. So look and get that implemented and turn it on if you can. Security is an afterthought. This one is kind of interesting. You can get really blacklisted in the market by doing things very poorly. An example of this, join keys, putting those on the QR code. So these are security keys. They're how you work with the device. So don't print those in the QR codes. You're essentially, it's the equivalent of printing your Wi-Fi name and password on your router, but the difference is, you're deploying these devices out in the world, so you don't want someone to just be able to see the password and the username for that device. In addition to that, though, ask your firmware team to show you an output of what they're printing out on the console logs. I also find a lot of firmware will print it out in the serial console exactly what the security keys are. This can also be a vulnerability. Some companies hard code this. They make all the devices use the same. So if you've got those 2 issues together, you've compromised your system. So make sure your firmware is not printing those keys out and treat those keys with respect. It's just a simple thing to do that will pay off in the dividends. In addition to that, look at how you're going to share the keys with the client. Going back to before that scale issue, how are you going to share the keys to the end client? Are you going to email them a CSV? Are they going to be able to download it? What's that process look like? And consider that and also a place of vulnerability. Security is always thought as an afterthought. It's only after there's a mistake. There's an old saying: you see the additional buy-in and the additional budget for security after an event. I think it was Netflix just went through a security event. Suddenly, you can see all the jobs posted online of all the security researchers. I understand the shoestring versus the behemoths that's got the budget, but the shoestrings can at least not hard code it and put it in the QR codes. So let's at least do the right thing there. The other funny story here is I've heard Amazon. I've had a client say, "Why do I need to worry about security? I run everything on AWS." Just realize that your developer's job is to lock the door. The tools are there, but your firmware guy has to lock the door. And unless you've spent the time in the project to say, "Hey, are my doors locked?" They're probably not, because they're focused on developing quickly. They probably enabled printing out the QR code in the serial log because they wanted to test quick. They wanted to be able to add it and not write it down and lose track of it. So no one's being malevolent here. They're just not taking the time to lock the door. And so unless we give them the time and tell them it's important, it's not going to get done. Final thoughts here, just a couple of extra things that I think are important to boosting revenue and avoiding cold data storage. What's interesting here, we create a bunch of data, and then we leave it in a database. We can access it at the click of a button. Let's collect temperature data, right? We store that in databases that we can query in an instant. If you're not familiar with cold data storage, that's kind of moving that data into an archiving it, if you will, zipping it and compressing it. It's important if we're going to fight cost here and really think about the way our data is being used. I promise you, you don't need that temperature data from 3 years ago, but if you think you do, at least move it into cold data storage. You don't need to be able to respond on an instant. You can still build AI models and things like that that can access data. The cold data storage doesn't mean it's not accessible. It just means that it's not as quick to access. Think about support. I have a comment in here around diagnostic payloads and things of that nature, but how does your team know if the device is online and if you have a bug? Think about a diagnostic payload that tells you how often the device is rebooting, how often it's booted. Think about how often the watchdog timer has happened. All of these things can trigger issues and things that you know, hey, I have a bug and I need to respond to it because this device is rebooting a lot in the field. Again, you might not see it at 1,000, but you might see it at 10,000. Think about your payload. You can do just because you have 11 bytes, I've seen things like the word temperature wrote out in what they're transmitting via LoRa. You don't need to do these things. You can be smarter with what the payload we're actually sending is. And that can offer a lot of efficiency and things for us to do better. So what does it look like when you do it right? We've worked with a company named InView. InView's in the retail security business. They launch a lot of products into Best Buys, Walmarts, these kinds of things. And we worked with them to create not only a photo solution, works across 5 different product lines. They've also got device-to-device communication. So they've got a panic button they can press and calls all the phones that you would normally pick up, and holding your hands with that cable causes them not to be able to come off the table, things of that nature. So really enjoyed working with InView. They're a marquee client of ours, and these guys are doing it right and investing and making things work correctly. So that's all I have on my side. Thank you guys for your time. There's a QR code up there. We're giving away a drone, so you can scan that and get a drone. But I also link to this presentation, so anybody wants to forward it to their engineering team and say, hey, these are some roadblocks you might want to think about, and my LinkedIn. So thank you guys. I really appreciate you listening. So take care.